Alright guys, I hope this video finds you well. It is kind of a little late tonight, me shooting these videos, but I'm going to get them uploaded for you very quickly. So remember that in chapter 3 there is only one section, and remember the emphasis of what we're doing as we start into our midterm is we're starting at solving and graphing inequalities. You also have to be comfortable with putting solutions after you solve the inequality in interval and set builder notation. Alright, so this video is going to be on one-step inequalities, and as I do quite a few, and if there's enough time, I would also try to squeeze in two-step inequalities, but I may just separate the video, so we'll see. Alright, so let's jump into it. We'll start with number 1. So what if I have negative 12 and it was greater than, so excuse me that I'm going to be toggling back and forth. There's also a little bit of lag in my stylus, so it may look sometime a little lines will show up as I'm writing. Okay, so as we can see, x is already on the right hand side, and so when we read that we have x minus 7. The opposite of subtraction is addition, so I'm going to add 7 here. What I do to one side, I'm going to do to the other. And the way that I distinctify my sides, you guys, is basically right through this inequality symbol, right, is my left and my right, okay, for the equation. So this is now gone. X is left on the right because we added 7, which made 0. We moved it over, changed the address, changed the sign to the left side, and when we have a negative and a positive number, we end up subtracting, right, and keeping the sign of the bigger number. So I'm going to drop down my inequality symbol, and this is negative 5. Okay, if this is hard to read, then remember I told you you could put your letter on the left. Notice that the inequality symbol is facing away from x, so I'm just rewriting it so I can read it now from left to right, and I have x is less than. When the inequality symbol is facing away from someone, it's a less than. If the inequality symbol is facing towards someone, it's a greater than. So if we graph this with our number line, we would have 0. Let's just say about here is our negative 5, and again we're reading x is less than, so we want all the values that are less than negative 5, right, which means we're going to the left. We get smaller as we're going to the left towards negative infinity. And also notice that below this inequality symbol here, there is no line. So we don't want to be less than or and equal to negative 5. We just want to be less than. So we're going to use a parentheses. And we're shading everything to the left towards negative infinity. All right, so that would be the graph. That's it. You put your number line, put your number, put your parentheses, face it the correct direction, and then shade. Now if we do interval notation, we're just going to transfer this information down. So we have parentheses, negative infinity, comma, negative 5, parentheses. So this is interval notation. And just to be clear, sorry again about my pen, to be clear, it's really important that you understand that negative infinity is always on the left of the comma. If we were going towards the right, it would be on the right side of the comma. Never do this. Never put negative 5 comma negative infinity. Okay, that's not how you write that. And remember that negative infinity and positive infinity always get parentheses. Okay, so that would be the graph up above. That's the interval notation. Now if I did set builder notation, it would be, put a little squiggly line like this, x, remember we always have to put that vertical such that, and you just write what your solution is. Okay, this is set builder. Alright, let's move on. So again, I give you all 3 solutions. Okay, so let's go on now and look at, let's try number 5. So for this one we have a minus 17. I think it was greater than negative 16. Yeah, greater than negative 16. Alright, so here we go for this one. Put a little up right here. So we have a minus 17. So to get rid of that negative 17 on the left, we're going to put a plus 17. What we do to the left, we're going to do to the right. This is now gone. Remember, we're solving for our variable, so a is now by itself. Greater than, we have a positive 17 and a negative 16. We subtract, we get a positive 1. Now we're graphing it. So I'm going to put 0. 1 will be here. And I look at my statement from left to right. So a is greater than negative 1. Remember, it's not greater than and equal to, so I'm not going to use a bracket. I'm going to use a parentheses. but I want to be greater than 1. So I want to face it towards the right and shade towards positive infinity. There we go. So that was the graph. Now for interval notation, notice we have our parentheses for our 1, comma, I have that positive infinity on the right of the comma, and remember, parentheses. So this is interval notation. And for set builder, we're going to say A, oh, I forgot the squiggly line, A such that A is greater than 1, squiggly line. This is set builder. Okay, so I hope this is all making sense to everybody. Good deal. Okay, let's try another one. So let's try number 8. So number 8 says 8 is greater than and equal to n, was it plus 6? Minus 6. Here we go. So for this one, I'm going to change colors. I see that it's n minus 6, so I want to add a 6 here, add to the other side. This is now gone. Drop the n down on the right side, staying there, and then 8 plus 6 is 14. Again, if you have a hard time reading this, remember I said put the letter on the left. Notice that it's facing away from the n with the equal to, it's facing towards the 14. So when we read this, we're saying n is less than and equal to 14. So if I do my number line, I'm going to say 0 is here. Let's say 14 is here. Notice that it says less than and equal to, so we're going to use a bracket instead of a comma, so we have to include 14 in our solution. So if I'm everything less than and equal to, my less than is going here, right, toward the left. So I'm going to put a bracket on the 14 and shade everything less than. So I want to shade everything going to the left toward negative infinity. Okay, so there's the graph. N is less than and equal to 14. So our interval notation will be parentheses. Notice that negative infinity is on the left of the comma, and then we have 14. But remember, no parentheses, we use a bracket, and here's interval notation. And last thing, let's show you set builder. For set builder, you would put your squiggly line in such that n is less than and equal to 14, and then you close it. And this is set builder. Now remember I told you the beauty of equations is you can always check your solutions, right? So let's say we go back to that green equation that I wrote originally, and let's choose a value that is less than 14. And a real easy number, you guys, is always 0. If you can use 0, it makes life really easy. So what I'm going to do is rewrite that problem. 8 greater than or equal to n minus, and again I'm going to check n equal to 0, because that's a value that's less than 14. So if I put 0 right here, right, n minus 0 is nothing, right? So, oh my goodness, I did the wrong thing. Hold on, sorry guys. Hello. I know what I did wrong. I needed to put in the 6, and we need to substitute the value 0 in for n. I apologize. So let's do this again. 8 greater than or equal to, again, where n is, we're going to put a 0 and then minus 6. There we go. All right, so remember I told you guys, now you know that 0 minus 6 would just be negative 6, but if you can't see it, remember I told you you can change that to a plus, bump back the negative. Okay, so basically there's your negative 6. So is 8 greater than or equal to negative 6? Yes, it is. That's a true statement. 8 is larger than negative 6, and so there you go. You've shaded the right direction. If you would have changed this the other way, okay, like let's say you would have accidentally, but you got to be careful, put a bracket here at 14 and shade it this way. When you choose a value greater than 14, like 15 or 16, you would get a false statement. And I'll just show you real quick. So let's choose n equal to 16, and let's just see what happens. So if I had 8 greater than or equal to, for n, we're going to plug in 16 minus 6. And if we did this math, we would get 8 greater than or equal to 16 minus 6 is 10. See how this is a false statement? 8 is not greater than or equal to 10. So this would be false, right? And since it's false, that's what I'm saying. You shaded the wrong direction. You know that you did something wrong. You need to relook at your steps. So I hope that makes sense as you can check yourself. All right, let's do one more with addition and subtraction with one step. And then I'll move to multiplication and division. Let's try number 2. Okay, on number 2, you know what? I'm going to do number 6. Yeah, let's do number 6. Clear my board off. All right, so for number 6, I believe I saw 15 plus x less than or equal to 0. Okay? All right, so for this one again, notice that the 15 is positive, and I see a positive sign there on the x, but we don't want to worry about that part. But the fact that our 15 is positive, that means we need to do subtraction. So that's minus 15. Minus 15. This is now gone because that's 0. And now I have x less than or equal to, and again, this is negative 15. Okay, so now when I graph this, 0, negative 15 is way over here somewhere. Okay, and when I read that from left to right, I notice that there's a line under the inequality, so I'm going to use brackets, and it says x is less than and equal to negative 15. So if I'm less than, I want to face to the left. And I want to shade all my solutions that are small going toward the left, okay, towards negative infinity. So the interval notation of this one is parentheses, negative infinity, comma, negative 15, bracket, and this is the interval notation of our solution. For the set builder, it would be x such that x is less than or equal to negative 15. Sorry for if you hear the yelling. Set builder. Okay, so I hope that these make sense about again, these are addition and subtraction one-step equations, and let me also show you that or mention that notice that I never flip the inequality when it comes to addition and subtraction. So now let's go into multiplying and dividing. That's where the inequality flips. Okay, so if I scroll down here, notice that again, this is coming from the PDF that's on the website. So if you want to check yourself and do more problems than what's in this video, please scroll down to the bottom to the 3rd and 4th page. There's the solutions. Now notice for a moment that on these solutions it may be a little confusing, not really, but they put the solid circle and open circle for the answers. But again, we're focused on doing set builder and interval notation. So the closed and open circles, just remember a closed circle would be a bracket, and open circle would be a parentheses. Okay, so it's the same thing. All right, so let's go now back to page number 1, and I'm going to start with doing number 9 and 10. So let's look at number 9. So for number 9, notice it was negative 3x, I believe, greater than 3. So let me toggle real quick back. Yep. So in this case, what's happening to x? Remember in the previous problems or the 4 examples I did before, we had like x minus 17 or 15 plus x. So we had pluses and minuses. In this case, we're going to look at multiplication and division, and we're solving again in one step. So what's happening to x? It's being multiplied. You see that they're close together, so there's marriage happening, multiplication. So x is being multiplied by negative 3. And the opposite of multiplication is division. And the opposite of marriage is what? Divorce, unfortunately, right? Remember I said that in class. So we're going to divide not by 3, but by negative 3. Make sure you take that sign with the number. So we're going to divide by negative 3. And what we do to one side, we're doing to the other. So remember, negative 3 divided by negative 3 is going to be a positive 1. So that's why these guys will cancel out. X is by itself. Now remember, when you are, and I'm going to put a little note, if you ever multiply or divide by a negative coefficient, you have to flip the inequality. That's coefficient. You have to flip the inequality symbol. Okay, so in this, I'll put the inequality symbol. I was going to put sign. All right, so because we first had a greater than facing toward it, we're going to face it away. And then we say 3 divided by negative 3 is negative 1. So remember, multiplication and division, and it's a negative. Whether you multiply or divide by a negative, you have to flip the direction. So now let's graph this. So we have 0. We got negative 1. Let's call it right here. And I read it from left to right. X is less than negative 1. And because it's a less than not equal to, then I'm going to use parentheses. So we want to be less than. So let's face everything to the left is less than. Shade to the left toward negative infinity. And here's our interval notation. Okay. And then notice we just did one thing. What did we do is that one step. We just divided by negative 3. And if we do set builder, x such that x is less than negative 1, this would be the set builder. Okay, so pretty straightforward. Now let's try another one. So let's try number 10. For number 10, it says n divided by 3 greater than 3. So in this case, what's happening to n? N is being divided by positive 3. So we're not going to do, in the last time we did what? Division. But here we already have division. We're going to do multiplication. So let's times 3. And if you want to, you can put 3 over 1 so you can see it. And then times 3 on this side. And so now that you have this, right, this is what it would look like. It's 3n divided by 3. See, 3 divided by 3 is 1. So see, the n would be by itself greater than. We don't have to flip the inequality, and then we have 9. Okay, so the answer is n greater than 9. Okay, if I go ahead and leave it like that, I could do the set builder just right off the answer. So we'll say n such that n is greater than 9. This would be the set builder. If they want us to graph it on a number line, it would be, put the 0 here, put the 9 here. And because I want to be n greater than, I'm going to face my parentheses to the right and shade everything greater towards positive infinity. And if I do interval notation, it would be parentheses 9, comma, infinity. This is interval. So I hope that's making sense. Let me do 1 or 2 more of these. Okay, let's go down here, some bigger numbers. Let's look at number 15 and number 16. Again, this is with multiplication and division. So for number 15, it was negative 13x. I believe it was less than negative 156. Yeah. Okay. So again, remember how we talked about, most of us know our multiplication facts all the way up to our 12s, or we should know them really well. So 13 is one that we're going to have to do a little work with, okay? So what's happening to x is being multiplied by negative 13. So we're going to divide by negative 13 because the opposite of multiplication is division. What we did to one side, we're doing to the other. That becomes a 1x. We're going to, again, because we divided by a negative 13, we're going to flip the inequality symbol. And now we're going to do T-bow, right? Top in, bottom out. That's T-bow. Let me erase that and rewrite it. It did something with my symbols. Sorry, you guys, for the kid in the back. So now we know a negative divided by a negative is a positive, but let's do top and bottom out. So I got 156 being divided by 13. 13 goes into 15 one time. Subtract, remainder of 2, bring down, and 13 times 2 is 26. So then we have no remainder. So there it is. So this is going to be a positive 12. And if we graph this, we have 0, we have 12, and we want to be x greater than. So we want to put a parentheses because it's not greater than or equal to, shade everything greater which goes towards positive infinity. There's our graph. For our interval notation, it would be 12 comma infinity, like that for interval. For set builder, x such that x is greater than 12. And again, you can check yourself. You could choose a value that is greater than 12, but do not include 12. And so there it is. And let's do one more. Let's look at number, well, I wanted 16 and 15 are similar actually. So let's do, I did not find one that had a dividing with a negative. Nope. That's fine. Okay, so let me do number 14. So for number 14, we got m divided by, I believe it was just a 5, greater than and equal to negative 5. Here we go. All right, so for this one, what's happening to m is being divided by 5. The opposite of division is multiplication. So we're going to multiply by 5. Again, you could put that over 1. What you do to one side, because you times 5 over here, you times 5 over there. On the left, it would be 5m divided by 5, which those cancel out to make a 1, right? So we would have m greater than and equal to, again, I did not multiply by a negative 5, so I did not flip the inequality sign. So I'm going to leave it just like it is, and we got negative 25. So m is greater than and equal to negative 25. So on our number line, over here would be 0, way over here would be negative 25. We'll put a bracket, and we want to be greater. So we're facing towards the right, and we want to shade everything greater than negative 25 toward positive infinity. So there's our graph, and then for interval notation, it would be negative 25, comma infinity, parentheses for interval, m such that m is greater than and equal to negative 25. This would be set builder. All right, so that's about 20 minutes or so, and I hope everything makes sense. Please make sure that you, if you want to do a couple more problems, you also have, again, Connect Math to do some of these if you would like. But again, these were just one-step inequalities, and the solutions are on page 3 and 4, and then I'll go ahead and do another video on two-step.